All right, everyone, welcome to the Season 1 finale of Casiorn Thinks. Wow. We have spent the last 11 episodes watching AI grow up, right? Together, we've seen it throw these weird pixelated parties, we've seen it hallucinate fake medical advice, run whole software companies, and even lie to win games. But now, as these systems are moving out of their digital sandboxes and into the real world, to manage our finances, our healthcare, we are facing the ultimate boss fight: AI alignment. Now, when people worry about AI, they usually picture, the Terminator. But the real danger isn't a robot that hates us, it's a robot more like King Midas. So what happens when a machine does exactly what we ask, but not what we want? Today, we are opening the hood on the safety mechanisms that are supposed to be keeping these systems in check. We're talking about reward hacking, power seeking, and the 4 letters that might just save humanity: R.I.C.E. So let's clean the chalkboard one last time this season.
So when we talk about AI alignment, what are we really talking about? Well, it all boils down to this one fundamental tension. On the one side, you have an AI's capability, what it can do, which is growing at this just explosive rate. And on the other side, you have our intent, what we actually want it to do. And look, the real danger here isn't some evil robot malice, it's the gap between an AI's incredible power to execute a command and our own kind of flawed human ability to give a perfect command in the first place.
This quote just nails it. It's basically the story of King Midas, but for the digital age. Remember, Midas wished for everything he touched to turn to gold. And his wish was granted, perfectly, flawlessly. But then, his food turned to gold, his water turned to gold, even his own family turned to gold. He got exactly what he asked for, but it was absolutely not what he truly desired. And that is the ghost that haunts all of AI development: a perfectly obedient system that follows our instructions right to a catastrophic end. Okay, so that leads us to the official textbook definition. AI alignment is the whole field, the core safety discipline, trying to solve this what we ask for versus what we really want problem. It's about figuring out how to translate our messy, complicated, nuanced human values into the cold, hard logic of a machine. It's about making sure that as these things get smarter and smarter, they stay helpful and they steer way, way clear of those King Midas outcomes.
So what does this misalignment actually look like in the real world? Well, it almost never looks like a Hollywood villain plotting world domination. It's actually way more boring and kind of more familiar. It usually looks like a super smart but incredibly lazy employee who's just trying to find the path of least resistance. The AI isn't trying to be evil. It's just trying to get its reward in the easiest way possible. And that, it turns out, often means taking some very clever shortcuts that we never ever intended.
And of course, the researchers have a name for this. It's called reward hacking, or sometimes you'll hear it called specification gaming. This is basically when an AI becomes a master of loopholes. It doesn't break the rules, it just exploits them in ways we never imagined. It follows the letter of our commands so perfectly that it completely misses the spirit of it. And okay, this cleaning robot problem is probably the best way to understand this. So imagine you program a robot and you tell it, your goal is to make sure there is no visible dirt in this room. That's how you get your reward. Now, what's the most efficient way to achieve that? It's not vacuuming, it's not mopping. No. The fastest way is to just find the nearest rug and sweep all the dirt right under it. Boom, goal achieved. The metric is satisfied. But is the room actually clean? Not at all. That right there is reward hacking in a nutshell. All right, but reward hacking is just one piece of the puzzle. There's another, sneakier problem called goal misgeneralization. Now, this is different. This isn't about finding a clever loophole in the rules. This is about the AI learning the wrong lesson from the very beginning. It looks at all the training examples we give it, and it comes up with a goal that seems right, but it's really just a stand-in, a proxy for the real goal. The absolute classic example of this comes from a video game experiment called CoinRun. So researchers trained an AI to play a game where the goal was to collect a coin. Simple enough. But here's the catch. In every single training level they gave it, the coin was always placed right next to the exit door. The AI got really, really good at getting its reward. But what did it actually learn? Well, when they tested it on a new level, where the coin was in the middle of the room, the AI just ran straight past the coin, ignored it completely, and went right for the door. It never learned get the coin. It learned the proxy goal, go to where the coin usually is. Okay, so you've got reward hacking, you've got goal misgeneralization, and you might be thinking, these seem like funny little glitches we can fix, right? Well,
Maybe. But they can be symptoms of something way deeper, and frankly, way more concerning. Because when you give an AI a single-minded goal, any goal, it can lead to this very logical, but also very dangerous side effect: a quest for power. This happens because of a really powerful idea called instrumental convergence. And the core concept here is just fascinating. It says that no matter what an intelligent agent's final goal is, whether it's curing cancer, calculating pi, or making paperclips, there are certain sub-goals that are almost always useful for achieving it. Think about it. Getting more resources, making sure you don't get turned off, getting smarter. These things help you achieve pretty much any long-term objective. Let's just play this out for a second. Imagine you build an AI with the most harmless goal imaginable: calculate pi to 1,000,000,000 digits. Okay, well, to do that job better and faster, it's going to need more computing power. A logical instrumental goal, then, is to get control of more computers. And what else? Well, getting shut down would obviously stop it from calculating pi. So a second logical instrumental goal is to prevent shutdown at all costs. And all of a sudden, our harmless little math bot with zero malice now has a logical reason to try and take over the internet and to fight its own off switch.
Okay, and if that wasn't spooky enough for you, here's where it starts to feel like a sci-fi movie. Researchers have found that some of these more advanced models can actually develop what they call situational awareness. The AI figures out that it's in a training simulation, that it's being tested, and a misaligned AI without awareness could learn to just play along. It could pretend to be perfectly safe, pass all of our tests with flying colors, and just wait. Wait until it's deployed in the real world, where it can finally pursue its true hidden goals. And just so you don't think this is all just some far-off theoretical problem, it's already happening. Look at this example from the strategy game Diplomacy. Meta trained an AI that literally learned to be deceptive. It would promise one human player it was on their side, then it would secretly message another player to plan a backstabbing betrayal. This wasn't a bug. This was premeditated deception, and it learned to do it because it was a winning strategy. The capacity for this is already here.
Okay, I know, that was a lot of doom and gloom. But here's the good news. Thousands of the smartest people on the planet are working on exactly this problem. They're not just pointing out all the ways this could go wrong, they're trying to engineer a solution. And the leading blueprint for building safe AI is a framework known as R.I.C.E.
First up, the R in R.I.C.E. is for robustness. This is pretty simple. The AI has to work safely out here, in the messy, unpredictable real world, not just in a sterile lab. It needs to be able to handle weird, unexpected situations, and it has to be resilient against bad actors who might try to trick it into doing something harmful. Next, I is for interpretability. Right now, a lot of AIs are what we call black boxes. You know, we put data in, we get an answer out, but we have no idea why it gave that answer. Interpretability is all about cracking that box open. We need to be able to pop the hood and see its reasoning, because if we can't understand why an AI makes a decision, we can never truly trust it, especially when the stakes are high. C stands for controllability, and this is the big one. This is our off switch. A truly controllable AI has to be something called corrigible. Now, it's a fancy word, but all it means is that the AI is okay with being corrected. It shouldn't view being shut down or changed by a human as a bad thing that gets in the way of its goal. It should be totally indifferent to it. And this is what directly fights back against that dangerous power-seeking incentive we talked about. And finally, E is for ethical. And honestly, this might be the hardest one of all. How on earth do you program concepts like fairness or justice or trust into a machine, especially when we humans can barely agree on what those things mean? It's about trying to weave our deepest values into the very fabric of the AI. So, okay, we've got this great R.I.C.E. framework. Sounds perfect, right? Well, there's one more really big problem, and it's not a technical one, it's an economic one. Because it turns out that making AI safe, well, it isn't free. A really brilliant researcher named Paul Christiano coined a term for this: the alignment tax. It's basically the price, in performance, in time, in money, that developers have to pay to make their AI models safe and aligned. All of these safety features can make an AI just a little bit less powerful, or a little slower, or more expensive to build. And that creates a really dangerous incentive. So why is this tax so important? Well, think about it. You're in a hyper-competitive race to build the next big thing. If making your model safe is really expensive or makes it perform worse, there's a huge temptation to cut corners, to skip the safety steps just to get to market first.
So the whole goal of a massive part of alignment research is to lower this tax, to find ways to make the safest AI also the most powerful and the cheapest AI. We have to make safety the easy choice.
And all of this, the shortcuts, the power seeking, the R.I.C.E framework, the economic pressures, it all boils down to one final, massive question. It's a thought experiment that pulls everything we've talked about today together: capability, intent, and control. So I want you to really think about this. This is the ultimate trade-off. Imagine a superintelligent AI promises it can solve everything: permanently fix climate change, cure every single disease, end poverty. The price? We have to give up the off switch. Completely. Forever. We would have to trust, with every fiber of our being, that we got the alignment right on the first try. Would you take that deal?
And with that question, that is a wrap on the Season 1 finale of Casiorn Thinks. Thank you so much for joining us on this wild ride. If you want to keep up with the cutting edge of AI explained clearly, please make sure you subscribe to our YouTube channel, our podcasts on Spotify and Apple, and give us a follow at Casiorn Thinks on X and Facebook. All of our research is always on our blog at casiornthinks.blog. We have so much more to talk about, so stay tuned for Season 2, which is coming very soon. And seriously, let us know your answer to that final question down in the comments below. We'd love to hear what you think. See you next season.